If you're up here speaking, please feel free to take it out. We have 6 talks in this session. Each talk has 15 minutes, including question answering and setup. So please try to be on time. For the audience, if you have questions, there are 2 mics. So please walk up to them. Ideally, say your name and ask your question. Those who are on Zoom, please type in your question and I'll read it out for the speaker. With that, let's get started. The first talk is on quality question answering with long input texts. Yes.
Hello. Hi, everyone. I'm Richard. Quality question answering with long input text. Yes. These are my amazing collaborators at New York University. Many models for natural language understanding can only process a limited number of words. Better long document natural language understanding can enable new applications such as news comprehension, novel comprehension, summarization, or other applied question answering tasks. So we're designing QuALITY, which is a benchmark data set that tests this long document understanding ability. For the existing work, there's the lack of good quality long context data sets. The contexts are short and questions are sometimes too easy. And many data sets are generation-based, which has evaluation problems. We also need to design better models in terms of longer context size, better retrieval and reasoning abilities. So here we are designing this high quality data set in the sense that the data set should have high human performance, and it actually measures the high level long context understanding ability. We also want to release the data set, including the articles word by word instead of URLs, so that the data set can be long lived. So we need to choose the sources wisely. So we end up choosing Gutenberg. The screen. Yeah, we end up choosing Gutenberg, Slate magazine articles, and other nonfiction articles. Most of the articles are from Gutenberg 20th century novels. And all of these articles are either CC BY or in the public domain. So we use the multiple choice question answering task to avoid evaluation difficulties for generations. And as you can see on the right, the input consists of an article that's about 30-minute read, and a question and 4 options. And the output is the option number that corresponds to the correct answer. The goal for each question is that we want each question to be correct and unambiguous, and we want each question to be difficult in the sense that it relies on more than a few paragraphs of context, and hopefully the question has good distractors, which are the incorrect options. So I'm going to first discuss the data collection strategies and then talk about our modeling efforts. So part 1 of the data collection is writing. We hire many freelancers. We interview them. We hire them on Upwork. And we ask them to read the entire article. And for each article, write 10 multiple choice questions that are correct and ambiguous and difficult. The base pay is $12.5 per article. And we use bonus schemes to incentivize the writers to write correct and ambiguous and difficult questions. And on average, writers receive bonuses on 42% of questions, and I'll discuss the bonus a little bit later. To identify questions that are too easy, we use speed validation or timed validation. The motivation here is that we want to ensure that the questions require understanding the full text to answer correctly. So if a person can correctly identify the answer to a question, such as through skimming or a Control F style in-browser search, then the question does not require a broad understanding of the passage, and models are likely to do well on these questions. So we ask mTurk timed annotators or speed annotators to do this speed annotation, and they only have 45 seconds to read the article and choose an option to the question. And as you can see here, the correct answer is B, and only 2 out of 5 timed annotators got it correctly. Because it's less than 50%, we label this question as difficult or hard. This method is inspired by adversarial data collection as a way of collecting more challenging data. A true adversarial design would not be practical because our models would have low performance and they will not provide enough signal to the writers. So we're designing this task in a way that writers can reason about what would be difficult for another human as opposed to a model. and we award bonuses based on this metric. The third part of data collection is end-time validation to ensure correctness and encourage difficulty of questions. So for each question, you see on the right, there are 5 annotators who annotate the question, also from MTurk. And there are 4 questions each of the 5 annotators need to answer. So the first question is the writer's question. And then there are 3 meta evaluation questions. So first, is the question answerable and unambiguous? Second, how much context is needed to answer the question? And third, what's the best distractor? The first 2 questions, so the first 2 columns are used to determine if the question is correct. And question 3 and 4 are used as feedback to the writers to encourage them to write difficult questions. Yeah, this is an important slide. So it's a correct question if 3, 4, or 5 out of 5 annotators think that the question is answerable and unambiguous. And 3, 4, or 5 out of 5 annotators pick the correct option in the end-time validation. And only the correct questions are included in the data set. Then it is a correct and hard question if the above 2 bullet points are satisfied, and only 0, 1, or 2 annotators pick the correct option in speed or timed validation. So if the question is correct and hard, then we award $1.2 of bonus to the writer per question. Here's the data split, and you can see that around 50% of the questions are hard. Another thing to notice is that there are only fewer than 7,000 questions. So it's not a big data set. So to do well on quality, the models are expected to have good transfer learning abilities. We also annotated reasoning strategies from the list on the right. And here's a quick example. I skipped the article, but the question is, what isn't a reason for narrator to be so skeptical of Gorb? And we annotated as why reason and not accept. Please refer to the paper for more details. But in general, many questions rely on reasoning about the best description, determining the correct explanation for why something happened, or the reader making an interpretation or using symbolism. The thing is that all these types are likely to rely on outer context from the passage, so hopefully they'll be more difficult. The second part is the modeling efforts. And there are 3 dimensions. So architecture, training set, and extraction retrieval strategies. For the architecture, as you can see, we use transformer, Roberta, Deberta, T5, and LED, which is a long-former variant. And only the long-former based models can accept most or all of the context. And the second dimension is the training set. So after initializing with one of the pre-trained checkpoint above, we can fine-tune the above pre-trained model only on quality or only on race, which is a much larger data set, but has much smaller context size. Or we can do intermediate training first on race and then on quality. The third dimension is extraction and retrieval. This is necessary because Roberta, Deberta, T5, and many other models can only accept a limited number of tokens. So we need to pick the most important sentences to fit in the models. So the intuition here is that we compute the similarity between each sentence in the article and the question. And we pick according to one of the 3 strategies below here. And we pick the top K ranked sentences in the article such that they can fit in the context of those models. So we only use the important sentences as the input to those models. But for long-former, we don't do extraction because long-former can already accept most or all of our context. And a few quick observations is that first, if we compare different architectures, so if we fix the training set and fix the extraction and retrieval strategies, we see that Deberta large generally performs better than other models. And second, if we compare different training data, so if we fix the other 2 dimensions, which is extraction retrieval strategy and fixing the architecture, then we see that if you only look at the blue box on the right, the number on the left is the full accuracy, on the right is hard accuracy, and random accuracy is 25%. You see that race quality is usually better than race, which is usually better than quality, much better than quality. So intermediate training works. And the third observation, if we compare different retrieval strategies, extraction strategies, while fixing the other two dimensions, if you look at the box, the blue box at the bottom, so if we fix the data and fix the model, which is the Berta V3 large, then we see that in general, fast text and DPR perform better than Rouge-1 recall. And observation 4 is this observation of full data set performance versus hard subset performance. And as you can see, the numbers on the left of the slash is usually higher than the number on the right, which means that the full data set performance is usually higher. So our strategy to identify difficult questions are working. And observation 5 is machine versus human performance. So our best performance is 55.4%. And we have a leaderboard, and current the state of the art is 62.3. We hired extra annotators from MTurk, and their accuracy is 93.5. So there's a huge gap, and machines are still performing miserably on this data set. So this is the leaderboard I want to advertise, and especially I want to advertise the SAT style score, which is number of correct answers minus a third times incorrect answers times 0 times plus 0 times the number of abstained answers divided by the number of questions. So here, if you guess incorrectly, then you're punished. But if you abstain, nothing happens. So if you just guess randomly, you will get an expected score of 0. So this is to encourage model abstention research. And there's this interesting research by the Metaculus community on what will be the best non-human SAT style score on the hard subset of quality by January 1st, 2025. And many people posted interesting analysis. So if you're interested, please check it out. And if you find this especially interesting, you can look at the other two forecasts, which is by year 2030 and by year 2040. And we also want to advertise this leaderboard by the Tel Aviv University, AI2, IBM, Meta. And the scroll benchmark also includes the quality results. And you see that long T5 XL doesn't perform well on this data set either. So the last slide. Crowdsourcing, as a recap, we have writing, speed time validation, and end time validation. And modeling, we have these 3 dimensions: architecture, training set, extraction, retrieval strategies. And for future modeling, maybe we can design better architectures or transfer learning strategies or extraction retrieval strategies. Or maybe we can explicitly model the entity relationships for better story understanding. And yeah, I'm curious to hear your thoughts as well. And before you go, feel free to grab a free tote bag designed by Dali and talk to NYU people. Yeah, thanks.
Thanks for the nice talk. Do we have any questions? There are 2 mics there. While people are thinking, I have one question. Yeah. Do you have annotation in the data set or in kind of evaluation where you assess the quality of explanations or identifying supporting sentences, supporting information within the long context?
No, we don't have annotations of like highlighting the articles. No, yeah, we don't have that. On the other hand, though, a bunch of NYU people, including Alicia over there, is working on a debate project. So feel free to talk to us. And the debate project involves highlighting important sentences. Yes, but that's a follow-up work, not included in this work. That's a great question.
Oh, and those who are on Zoom, please. Looks like we do have a question here. So it says, continuing the first question, do you think the difficulty is in retrieving the relevant part of the long text, or does the answer involve reasoning over multiple parts?
Sorry, what's the last part of the sentence?
Is there difficulty in retrieving, or is it answering by reasoning in multiple steps?
I think both, and better retrieval can definitely improve the performance by a lot. So in the appendix of the paper, so right now we're doing extraction based on comparing the similarity between each sentence in the article and the question. So if you compare the similarity between each sentence in the article and the oracle answer by cheating, then if you extract that way, then the performance will be much higher than 70-something%. So retrieval can definitely improve the performance because DPR is for passage. So maybe we can create a better version of DPR for articles, for sentences. But reasoning is also important, especially for novels. I think it's hard to keep track of the entity relationships, like twists and turns of the story. So both. Thanks.
Great. Let's thank the speaker.
Yeah, thank you.
The next speaker.